Alright, this worksheet is 4.3b. Number 1, they're asking you to find the equation of standard form of the parabola passing through those 3 points. So for number 1 and number 2, what we're going to do is we're going to do the long way, where we have to use elimination. And then starting on number 3, we'll use the calculator. So we have to get our 3 equations here. So we have -2 equals a plus b plus c. That's the first one. Remember, from the first video here, all we're doing is we're inputting -2 for y and 1 for x in the standard form. So y equals ax squared plus bx plus c. This point will have -2 equals 4a plus 2b plus c. And the third one will have -4 equals 9a plus 3b plus c. So the first thing we're going to do is we're going to take these two, put them on top of one another. -2 equals 4a plus 2b plus c. Leave a space. And we're going to multiply the top one by a negative. So we get 2 equals -a minus b minus c. The c's cancel. So we're going to have 0 equals 3a plus b. What we'll do now is we'll take the second and third, put them together. Draw a line. Multiply the top by a negative. So we'll have 2 equals -4a minus 2b minus c. So we add down, so we get -2 equals 5a plus b, and the b's cancel. Now that we have these two, we can put these on top of one another. Multiply the top by a negative. So we'll have -2 equals 2a. B's cancel. Divide by 2. A is -1. Once we have a being -1, we can stick it in here or here and solve for b. Put it in here. So 0 equals 3 times -1 plus b. Add the 3 over. b is 3. To find c, we have to put a and b into one of these equations up here. So let's put it in the first one. So -2 equals a plus b plus c. Subtract 2. So we have a, b, and c. So we'll just write this out as a function. F of x equals -x squared plus 3x minus 4, and there's your answer. Number 2, let's do the exact same thing. Let's plug one -2 in. -2 equals a plus b plus c. Second one, -4 equals 4a plus 2b plus c. And the third, -4 equals 9a plus 3b plus c. Alright, let's stick the first two together. Put a line. Multiply the top by a negative. So 2 equals negative a minus b minus c. So we get negative 2 equals 3a plus b. Let's take the second and third and put those together. And negative 4 equals 9a plus 3b plus c. We'll multiply the top equation by a negative. That will eliminate the c, so we have 0 equals 5a plus b. Let's put those two together. Draw a line. Let's get rid of the b's by multiplying by a negative. So we get 2 equals 2a. Therefore, a is 1. If a is 1, we can stick it into one of these two. I'll put it in the second one. So this is 5, so we subtract 5 from both sides. That gives you b. Now let's put a and b into the top left equation. So negative 2 equals a plus b plus c. Add 4 over. So now we have a, b, and c. So let's just write this out as a function. Ax squared be 1 times x squared minus 5b plus 2, and there's your answer. Alright, let's bring in our calculator. And let's enter these values in. So let's turn it on. Let's hit stat, enter. It's all clear, so that's good. So let's enter our x values. So 3, 1, and 6. 3, 1, 6. Let's move over to the y values. Negative 6, negative 2, 3. Negative 6, negative 2, 3. So our coordinates are in. So let's quit out of that. So stat, calculate, a quad reg, which is 5. And then let's go down to calculate and hit enter. So we have 1, negative 6, and 3. So let's just write down our function then. So a was 1, b was negative 6, and c was 3. So our function will be f of x equals x squared minus 6x plus 3. Number 4. First, they're asking us whether a quadratic model exists to begin with. So let's just take a quick look here at what the plot would be. So negative 1, 2, 3, 4, 5, 6, 7. Negative 1, negative 7 would be right here. 1, 1 would be right here. 2, 3, and 3, 1 would be here. So basically we just need to ask ourselves, is that in a straight line? Are those 3 points in a straight line? And they're definitely not. So the answer is yes, there is a quadratic model that could exist for that set. So let's bring on our calculator here. Let's quit out of that. Let's go to the edit. Let's clear out those values. So we're going to put in the x values. Remember, the x values would be negative 1, 1, and 3. So negative 1, 1, and 3. Y values, negative 7, 1, and 1. So those are our coordinates. Let's quit out. Stat, calculate, 5. Let's go down to calculate. So A is negative 1, B is 4, C is negative 2. So let's write those down. -1, 4, and -2. So let's write our function. F of x equals -x squared plus 4x minus 2. Number 5. We've got 3 points there, so let's bring the calculator out. So let's go to the edit screen. Clear it all out. Enter our x numbers, x values, -1, 0, 1. And the y's, 4, 1, 0. Let's quit out, stat, calculate, 5, enter. 1, -2, 1. That's my A, B, and C. 1, -2, 1. So the function is going to be f of x equals x squared minus 2x plus 1. The question is asking us to name another point on the parabola other than these. So what we're going to have to do is we are going to have to show our work to see a different point. And you could do anything else. You could enter 2, -2, 3, 4. Let's just do 2. So if I input 2, it's going to be 2 squared minus 2 times 2 plus 1. So 4 minus 4 plus 1 is 1. So my point is when I enter 2, I get an output of 1. That's an additional point on the parabola. Number 6. Let's get the calculator out. Let's clear out our x and y values. So our x values, 0, 1, 2, 3. So 0, 1, 2, 3. The y values, 46, 63, 48, and 1. Let's calculate 5. So -16, 33, and 46. So A is -16, B 33, C 46. So our function is going to be f of x equals -16x squared plus 33x plus 46. That's the model for that. We are going to work a little bit with this model because we're going to actually have to try to calculate something in regards to number 10. But we'll get there when we get there. Number 7 gives us 2 points and asks us the equation of the line in point slope form. So we want to find out what the slope is first. So the difference of the y's is going to be 2 minus 8 divided by the difference of the x's. So 6 minus -4. So we're going to have -6 over 10, which is -3/5. So we have two possibilities. Y minus 8 equals -3/5 x plus 4. That's using the first coordinate. Or using the second coordinate, y minus 2 equals -3/5 x minus 6. Alright, number 8, they ask you to graph the parabola. So we can start by plotting the y-intercept if you want, which is at 1. It's not a large point. There we go. We do want to find the vertex, though. We always want to find the vertex. So the opposite of b over 2a. So we have 2 over 4/3, which is 2 times the reciprocal. 2 goes into 4 twice, so 3/2. So that's our x-coordinate of the vertex. Our y-coordinate is going to be the output when x is 3/2. So let's plug that in. 3/2 squared is 9/4. This 2 and 2 cancel, so we're left with -3 plus 1. 3 goes into 9 3 times. 2 goes into 4 twice. So y equals, we're going to have 3/2 minus, we're going to make this halves also, 6/2 plus 2/2, which is 3 minus 6 is -3. -3 plus 2 is, sorry, my mind's fried right now. 3 minus 6, -3. -3 plus 2 is -1. So -1/2. Alright, so let's plot the vertex. So it's going to be 1.5, comma -1/2. So right there. So to find my point of symmetry, this point of symmetry is 1.5 units to the left. So I'm going to go 1/2 and 1 to the right. Put that there. Now, in order to get an additional point, we don't only want those 3 points. We want something other than that. So what we can do is we can input 4 into this equation and get an output. So y equals 2/3 times 4 squared minus 2 times 4 plus 1. If you do all that out, it's going to be 3 2/3, I believe. I can do that out down here. So 2/3 times 16 minus 8 plus 1. 2/3 times 16 is 32/3. If I'm making these thirds, it's going to be 24/3 plus 3/3. So 32 plus 3 is 35. 35 minus 24 is 11. So that's 3 2/3. So when x is 4, we're going to go up 3 2/3. So that is 1 unit to the right of this. So it's going to be 1 unit to the left of that. So we'll have a point roughly there. So we can use, that's an awful graph. Let me do that one more time. That's a little better. So there's your graph. Number 9, graph it in vertex form. So we're going to need to find the vertex. So the opposite of b over 2a is -6/4, which is -3/2. Now we have to plug that in to find out my output. So y equals 2 times -3/2 squared plus 6 times -3/2 minus 3. 2 times, this is 9/4. 6 and 2 can cancel, so -9 minus 3. The 2 and 4 can cancel. So 9/2 minus 18/2, we can make this halves, minus 6/2. 9 minus 18 is -9. -9 minus 6 is -15. So in vertex form, it will be y plus 15 halves equals 2 parentheses x plus 3 halves squared. Alright, number 10. What would be a reasonable domain for number 6? Explain why. Let me just go back to number 6 for a minute. Number 6, if you look at the graph of it, and I'm going to bring that graph up here. Let me input the graph. So let's type the graph in. So negative 16 x squared, so x squared plus 33x plus 46. Enter. And now before I hit graph, I'm going to click on the window. In terms of a domain for this, the lowest x that I put in here was 0. And it makes sense because you don't want the domain to be any less than 0 because time can't be negative. So we're going to have 0. What's my max time that I want? Well, it's not going to be much higher than 3 because a time of 3 will give you a height of 1. So when the time, let's say, is 4, the height looks like it's going to be less than 1. But we don't want height to be negative because it won't make any sense to have a negative height. So it's not going to be much higher than 3. So let's just go to, let's say, 5. It's not even going to be close to 5, but let's make 5. We go up by 1. The outputs, what's the lowest output? Well, the lowest output that we want is 0 because height won't make any sense if it's negative. What's the highest output? Well, it looks like 63 might be the highest, but we don't know that. So what we're going to do is we're going to go, let's make it 80. And we'll go up by 5. And that will be good. So let's hit graph. We should have a good picture of the graph now, of the height. So when time was 0, the height was 46. When the height was 3, when the time was 3, the height is 1, so on and so forth. So what number 10 is asking is what makes sense for the domain. We don't want to say it's all reals because negative values won't make any sense. Would it make sense to say x is greater than or equal to 0? Anything on the x greater than 0? No, it wouldn't, because would 4 make sense? No, because 4 doesn't have an output. Well, it would technically have an output, but it's way down in the negatives. But height being negative makes no sense. So what we want to do is we want to have it from 0 up to where it hits 0 here, where it hits the x-axis. To find where it hits the x-axis, what we can do is we can do second trace, so second calc. And we want to find the 0. Where does it hit? Where does it 0 out? So we want to hit 2. It's going to ask us left bound. So what we want to do is put the cursor anywhere above the x-axis. So that's above, that's fine, so enter. Now the right bound. So we want to drag this down, so keep going, until the output is negative, meaning under the x-axis. It's getting close. Now see, y is negative now, so it's under the x-axis. So we hit enter. And we want it to guess, so we hit enter. So basically it's telling us when x is 3.0158095, the output is going to be 0. Anything beyond that is going to give us an output being negative. So we want to remember this number. So you want to jot that down. Let's jump back to number 10. And you want to write out your answer. So basically, the domain is the set of all x's such that x is going to be greater than or equal to 0, but less than or equal to that number, that long number, 8095, something like that. This is our domain. Explain why. Well, what you would do is you explain the fact that x is greater than or equal to 0 because time cannot be negative. Also, x has to be less than or equal to that magic number because the height can't be negative. Meaning, if x was higher than this, the height would be negative, so it's got to be below it. So if you take these two things into account, you get that domain. And that's it.